Alright, today we are talking about severe weather. Finally getting to talk about tornadoes, hurricanes, and thunderstorms. And one thing all of severe weather has in common is they all happen in an unstable atmosphere. And when I say unstable atmosphere, I really just mean that air is rising. Okay, rising air means unstable. So then a stable atmosphere is the exact opposite. It's either air not moving at all or subsiding and moving down. So since an unstable atmosphere is the key feature to severe weather, what are some different ways we can create an unstable atmosphere? Some of them are what we've seen before with fronts. It's called frontal wedging, either at a warm front or a cold front, and mainly the cold fronts with that very rapid lifting of warm air. Another way to make an unstable atmosphere is through convergence at a low pressure. So wind all traveling into a low pressure only has one place to go, and that is up. And that means it's an unstable atmosphere. And the last one we're going to take a close look at is orographic lifting, or really the movement of air over, let's say, a mountain range. This idea of orographic lifting is going to show up on the test and the exam, so make sure you're taking some good notes here. And with orographic lifting, you're having an air mass move up and over a mountain range. There's two different sides of that mountain range. We call them two different things, and they have two completely different set of characteristics. On the windward side of a mountain, this is where air is rising. Air, let's say maybe an air mass coming off the Pacific Ocean, might rise over top of the Cascade mountain range. And as that air mass is forced upward over top of the topography, the mountains, it's going to rise and expand and cool and condense and form clouds and have precipitation. So the windward side of a mountain is usually a lot more precipitation, and it's usually cooler temperatures. A city that you might have heard of before that's on the windward side of a mountain range is Seattle, right over there on the Pacific Ocean. And if you know anything about Seattle, it seems like it's always kind of dreary and rainy in Seattle. And that's because the city sits on the windward side of the Cascade Mountains. The leeward side of the mountain range is completely different than the windward side. This is where a lot of the moisture has already been wrung out of that air mass, and so as it goes down the other side of the mountains, it is now a dry air mass. And because it's moving downward, the air is being compressed by air pressure, making it heat up. So the leeward side of a mountain is usually very dry and much warmer. Moving on to some specific severe weather. The most common severe weather we might have are just simply thunderstorms. So thunderstorms normally form through this frontal wedging at a cold front where we lift up this warm air. Sometimes, on occasion, it can happen just with unequal heating and cooling of Earth's surface, but not normally. And when we think of thunderstorms, the place on our planet that gets the most thunderstorms is actually the tropics. And they usually always occur in the afternoon. And there's a reason for both of those things. And when you think about the tropics, maybe you think about rainforest. And it's called a rainforest because of the precipitation it gets. And it gets all of that precipitation, again, usually in the afternoon, because all morning long, the forest and the land and the dirt and the soil is gathering up solar radiation. In the afternoon, it releases that radiation and it heats up the atmosphere. So every afternoon, you have this warm air rising into the sky that causes the air to rise and expand and cool and condense into clouds and form precipitation and sometimes thunderstorms. And these thunderstorms, they don't normally last too long, and we're actually going to see that they actually extinguish themselves. You're going to want to make sure you have this diagram drawn down. It's showing the growth and development of the thunderstorm that eventually leads to how they extinguish themselves. In the first stage, it's called the cumulus stage. And that's when we have a lot of this warm air rising, and as it's rising, it's expanding and cooling and condensing, forming clouds, and eventually we'll get to precipitation. The phase that we want to kind of focus on here is in the middle, and it's called the mature stage of the thunderstorm. And the mature stage of the thunderstorm is just when we have both updrafts and downdrafts. We have both warm air rising, which is giving the power, it's giving the energy to the thunderstorm. This thunderstorm would not be there if it wasn't for this warm rising air. But at the same time, we've already had so much warm air rise into the sky and cool off, and that cool air has to come down. It's increased its density, and it's moving down towards the surface of Earth, producing a downdraft. So in the mature stage, we have both updrafts and downdrafts. But eventually, so much warm air rises and cools that the cloud is entirely taken over by downdrafts. It forces warm air to remain at the surface, and there's no more warm air rising. The storm just fizzles out, it dissipates, it breaks apart. And this is kind of what happens with the majority of thunderstorms. And before we get to tornadoes, there's one key feature of severe weather that we need to call out, and it's just wind shear. Wind shear is when the wind is moving opposite directions, almost like scissors move opposite directions, shears, right? Wind shear is very important for producing severe weather. And there's two different types. There's either a vertical or horizontal wind shear. Vertical would mean that some air is rising and some is sinking, like we just saw with our thunderstorm. But sometimes we can have this really strong wind shear that is horizontal, meaning that wind on the surface of Earth is moving one direction and wind up higher might be moving in opposite direction. That also is a wind shear. And both of those types of wind shears come into play when we talk about the formation of a tornado. And tornadoes are just very scary forms of weather. They normally happen in the springtime with this mixture of maritime tropical air masses moving up from the Gulf of Mexico and continental polar coming down from Canada. Tornadoes are described as extreme low pressures, and you'll usually see that they're the shortest lived but highest wind speed. And because of this really high wind speed, we also consider it to have a very steep pressure gradient. And there was a tornado right here in Hudsonville in 1956. And the way tornadoes usually form is through a horizontal wind shear. So again, that's when air on the surface is moving one direction and air higher in the atmosphere is either moving the same direction but at a different speed, or it could be moving at a completely different direction. And so with tornadoes, they normally form laying down on their side with an air mass kind of tumbling or rolling. But then we have a vertical wind shear that takes this tumbling or rolling air mass, and the vertical wind shear would lift up one side of that tornado. So then we would end up having a tornado, that cyclone shape that everyone is familiar with. But it's pretty interesting that they can be detected as they're lying down. And that's really what all those meteorologists, the storm chasers, are looking for. They're looking for wind shears as they go up and down, sending up weather balloons, looking for wind speed and wind direction. The next type of severe weather we're going to talk about are hurricanes. And hurricanes, thankfully, not something we have to worry a lot around here. Michigan is safe from hurricanes. But if you happen to move around the country or end up on Florida or the coast, you may be impacted by a hurricane. And hurricanes, they are normally forming in the late summer, so like August or September. And that's really important because hurricanes, they get their energy from warm evaporating ocean water. And there's even like a specific temperature necessary to have the amount of evaporation to form one of these hurricanes, and it's 80 degrees on the dot. So when the surface of the ocean gets to be 80 degrees, that means there's enough evaporation to potentially form a hurricane. And the surface of the ocean doesn't get to that number, that 80 degree mark, in the springtime. It takes all of summer for the ocean water to warm up to hit that mark. And so with this huge amount of evaporation that takes place, we're adding water to the column of air, to the air mass. And you should remember that when we add moisture to an air mass, it causes the air pressure to lower. So we're creating these massive low pressure areas simply by evaporation, just adding water vapor. And so a hurricane, when it gets to land, it usually breaks apart because it no longer has that warm surface water evaporating, giving the hurricane energy. So again, important stuff to remember is that they happen in the late summer and they get their energy from warm evaporating ocean water. And to wrap everything up, we had to put this somewhere, but we need to talk about precipitation. And there's some precipitation we don't need to talk about too much, like rain and snow. That's pretty straightforward. But the precipitation we need to talk about are the differences between sleet, freezing rain, and hail, because they often get confused. And starting with sleet, sleet is when frozen rain pellets hit the surface of Earth. So to have that happen, a raindrop has to fall through the atmosphere, and it has to fall through a layer of the atmosphere that is below freezing. And this layer of the atmosphere is usually very thick. So as that raindrop falls through this cold layer, it completely solidifies into a solid chunk of ice. And it falls out the bottom of this layer of the atmosphere and eventually reaches the surface and hits the surface as a tiny little droplet of ice. Freezing rain is kind of similar, but it's different, big time. It still starts as a rain droplet, and it still falls through a cold layer of the atmosphere below freezing. But this time that layer of the atmosphere is very thin. It's much thinner than the layer that produced the sleet. So what that means is that this rain droplet does not completely solidify. It just lowers the temperature right to freezing. So it's still falling as a droplet of water that's very, very cold. And that droplet of very cold water, when it hits the surface of Earth and it spreads out, the surface area changes, and that allows it to instantly freeze to ice. And so again, the big difference between sleet and freezing rain is really the thickness of that cold layer in the atmosphere. And then we have hail. Hail is formed when a rain droplet is caught in the updraft of a thunderstorm. And if you remember the mature stage of a thunderstorm that we just talked about, there are both updrafts and downdrafts. Normally the rain falls in a downdraft, but occasionally some of that rain can get caught in an updraft and it's thrown back into the sky where it's very cold and it freezes. As that now frozen rain pellet falls down in the downdraft again, it gets more moisture added to the outside. But if it's caught in an updraft once again, it's thrown back into the cloud and that new layer of water freezes. And this process of falling down in a downdraft, getting extra water added, caught in an updraft to refreeze, this process happens over and over and over, and it ends up adding layer after layer after layer to the hail, until eventually the updrafts just become very weak, or the ice gets so large, the hail gets so large that it exceeds the force of the updraft and it falls to Earth. But eventually that hail will get large enough it will end up hitting the ground. And the cool thing about hail is that you can take a sharp knife and cut open a chunk of hail. And you can see almost like tree rings. You can see rings in the chunk of hail, and that represents how many trips it took up and down in a cloud. It's really cool. All right, that's all we have today for severe weather and precipitation. If you have any questions, please make sure you're asking. Please make sure you're taking some good notes, and I'll talk to you later.